Hello. Hello everyone. For initiated, I'm Lauren. I'm one of the organisers here at NIDC. I'm just up here to say a couple words first before we get started for tonight. So first things first, thank you everyone for coming down and taking time out of your Wednesday evening to be here. It's very much appreciated. And big shout out to our AINI organisers, Jordan and Chloe over there. Give us a wee wave. And also our lovely speakers for putting themselves forward. And I really appreciate the time and energy everyone's put into organising tonight. It hasn't been easy coming back after a year and a half, or maybe even 2 years, but very much appreciated. And to all the attendees, please, between all the talks, turn around and chat to each other. You might see some familiar faces, or you might even get to meet some new people. So tonight is as much as it is your night as it is ours, so just make the most of it, because the whole point of NIDC Meetup Week is to bring back the local tech community together. So make the most of it. Apart from that, between the talks, make sure to grab more food, grab more drinks. If you are grabbing more food, make sure Mark here has his dinner lady gloves on to try and prevent the cross-contamination and all that good stuff. But yeah, that's all for me tonight. So if I can pass on to Jordan now, or MC. But yeah, enjoy your evening, folks.
Okay, hello everybody. And as Lauren mentioned, we're really pleased to partner with the Northern Ireland Developer Conference to support this entire Meetup Week agenda. So first I want to thank both Lauren, Mark and Art for a lot of what they have done to help organise this. They've frankly made life quite easy for myself and Chloe, so I really appreciate it. So when I was reflecting on this event, the one thing that came to mind for me is this is the first in-person AINI event we've done 2 years and 10 months. That's a long time. So when I reflected on this, I really started to feel a lot like Robin Williams out of Jumanji. So for perspective, if we jump into our time machine and think back to 2 years, 10 months ago, at that time I don't think I knew what a TikTok was, beyond being the sound a clock makes. The hopes were soaring at Manchester United that Ollie was at the wheel. So sorry, Man United fans. So times have changed, and I'll let you decide which one is for better or for worse. So tonight is a tale of two Jordans and two topics. Number one is going to be around browser-based teachable AI and ML. My talk is going to be around AI and machine learning applied to e-commerce. So this is a really bite-sized AINI event. Both Jordan and myself will present directly and will remain behind for any conversation or discussion anybody wants to have with us. But we're going to start with the McDonald variant of the Jordans to kick us off first. So today I'm going to tell you a story, and it's going to be about one of the many examples of machine learning in the world of e-commerce. And it's actually an industry in which I started my career as part of a startup building recommendation engines. And I'm going to express this story through the lens of Bazaar Voice, who's the company I work for, of course, nowadays. And if you don't know who Bazaar Voice are, they are the largest rating and review provider in the industry, and I help lead the AI/ML strategy and delivery with the company. So I'm going to apply this lens to a scenario and some additional goals. So we're going to touch on 3 big ideas today. Number 1, we're going to introduce a few key concepts for ratings and reviews providers. And those 2 concepts are syndication and matching. Bit of jargon around those, so don't worry, I'll explain what those are and explain them in plain English. Goal number 2 is going to be about applying machine learning towards the product matching scenario that I'm going to set up in the next few slides. And finally, I'm going to talk about the benefit realization of this work and beyond the wider impacts of it. But before I do that, I'm going to jump into our hot air balloon, elevate ourselves to 20,000 feet, and start from the very tip top. So, 1 billion products, 50 million reviews, 12,000 brands. If you take these distinct ingredients and blend them together, you've got a cocktail of challenge that I'd best describe as the most complex game of Snap in the world. And this is big data in its most explicit sense, and it's data that's entirely managed by Bazaar Voice. But data on its own is useless. Data's value is in how it's used. So there's a big question for the organization. With the enormity of this data, how do we leverage it to enable product syndication? So you will be unfamiliar with that term. You might hear syndication and think about the syndication of US TV shows like Friends and things like that, or even the villainous group from the Mission Impossible series. I know that's the first thing that came to my mind. But this is a different idea entirely in the world of Bizarre Voice. So there's no Tom Cruise, you're stuck with me, sorry about that. So I'm going to introduce these core ideas involved in that keyword syndication for the mechanics of a card game. In this case, the game of Snap. I'm assuming everybody here has played Snap before. I see lots of nodding heads, which is good. So Snap, in essence, is the prototypical matching game in the world of playing cards. And there's many variations on the rules of the game, but I'm going to start with a couple of simple scenarios within the game of Snap. As in all playing card games, you have a deck, and the cards range across the 4 suits and the typical ranks, so ace through to king. So let's say we draw a card from the deck. This case is the 5 of diamonds. And we draw a second card from the deck. We try to remain alert to discover a match, and that's when you shout snap or slam your hand across the deck. In this case, it was the 8 of spades. So is this a match? No, it's not a match. We consider it a match in the rules of Snap if the 2 cards have the same rank. So 5 and 8, of course, are not the same. So that's the lens that we'll play this game through. So let's pull from the back of the deck again. And we can see here we've got the 8 of hearts. Is this one a match? It certainly is. This is a Snap moment. And it's a sad state of affairs that I associate the word Snap with Snapchat, which is quite disappointing. But the rules of Snap are surprisingly like the rules we follow in the world of syndication of reviews and Bizarre Voice. As much as it's hard to believe, the connection will become quite clear soon. So with these 2 fundamental concepts in mind, let's connect these 2 words. In Bizarre Voice, clients give us product catalogs, and catalogs often have many products. For example, we have a snazzy pair of running shoes here that the review says are dope sneaks, and I completely agree. And products are often associated with ratings and reviews, as we see here in this example. And this is where Bizarre Voice comes into play. One of their key business offerings is the provision of ratings and reviews for hundreds of clients, ranging from heavy hitters like Walmart in the US. So we have a product, and a product is bundled around what we call a GTIN, which is a global trade item number. So that's essentially a unique identifier for the product. And in this case, the GTIN is 8420429. So that's entirely unique in theory for that product. And RAID GTINs are the key component that enables review syndication. So it's time to answer that question. What is syndication? It's certainly not the antagonist of the Tom Cruise movie that I mentioned before. It's something completely different. It's really, in simple terms, the linking of products across client catalogs. So this link, if you can establish it, allows clients to share reviews. And you might be thinking, why would they want to do that? What's the benefit of this? Well, more reviews equals more trust, equals more sales. And that's something we know intuitively as shoppers. If you're on Amazon, the more reviews that are on a product, and the better the reviews are, you're more likely to buy it. So reviews matter. For me, very recently, I have an example of this. As many of you probably know, the Shark vacuum cleaner company had quite a few deals come out of Black Friday. So I spotted one that was quite space age and really caught my eye. And really spoke to the tech nerd in me. Quite expensive as well. It was actually the reviews that tipped me over the edge to buy it. So I think that shows the power of reviews. So this is a visual example that we're seeing now of product syndication. We have a pair of shoes that are produced and sold by Nike. And the aim of syndication is to link the same pair of shoes across several client catalogs. So client A in this case could be Walmart, client B could be JD Sports, or whoever else is selling the Nike shoe. It doesn't matter. The important thing is the sharing of the product. So what this means is a review submitted on the Nike website will be shared to all of the other websites that also have the same product. So let's bring this example into the real world. We have two Bizarre Voice clients here. One is Kidcraft, which you see here on the left, and another one is Target, which is the large US retailer. So these are two entirely different websites, but if you keep a close eye on what the reviews are, it's the exact same reviews. This is review syndication, and it's a massive driver at the heart of e-commerce for increased sales. So this is a really simple idea, but the mechanics of supporting this is actually very, very complex. So what goes on behind the magician's curtain? Let's imagine we have two client catalogs. Client A, let's say they sell ceramic avocados, for example. Client B, they sell the same thing. So it's a boom industry, I guess you could say. And within their catalogs, the squares could represent products, and the numbers aside, the squares could represent the G10, so that unique identifier. So what we do in Bazaar Voice is we ingest these into the Bazaar Voice syndication system, and an automatic matching process occurs. If the G10s match across the two catalogs, great, that's a link and we can trust it. But where it really gets interesting is when we can't match on the G10. And this is what we call manual matching occurs. And this entire process you see in the slide deck, you can think of this as product matching, and this is everything behind the scenes that supports it. And it's really at the heart of review syndication. So let's zoom our focus onto that orange box. By definition, manual matching is quite manual. And you might be thinking, why? Well, it's an entirely human-driven process. And we have a team internally who use in-house applications to essentially compare products on a web page side by side all day, every day, and have two options, either approve or reject a match. This is slow, it's repetitive, and it's time-consuming. And it's demonstrated, I think, by one simple number. And that number, while it's simple, is quite big. It's 1 million. That's the number of manual decisions this team makes in a month. So imagine at the course of over years when this has been happening. So what was my reaction when I saw this? I'm sure you've had a few as well. Well, it was a little bit like this. My spider sense was tingling, but not for danger, for opportunity. This was a machine learning opportunity. So like a gun to the face, the synergy of machine learning and business opportunity was absolutely undeniable. And this is where I started to frame my hypothesis as someone identifying an opportunity for machine learning here. Is this possible to apply machine learning to this manual matching process? So instead of relying entirely on the humans, we could do it automatically. Ultimately, the goal here is to build a solution that could work alongside the human team as a collaborative force. So that allows that entire moderation and manual matching process to dedicate their time to the actual difficult matching decisions, not the ones that are easy. So if we put our solution hat on, where did this solution start? The instigating event was actually an internal hackathon. And funnily enough, this happened to be my first week with the company as well. So I was a lot of ways tossed into the deep end. But luckily, there is gold on the ocean bed in this case. So over 2 days, working on this hackathon, we demonstrated the art of the possible and really planted a seed of possibility that showed that this was possible. Machine learning could help here. The next step was to collaborate with product leaders in the entire syndication space to bring this in as a key development item as part of the product roadmap. And that's where the ML development cycle began. So the big question you might have is, how do we bring this work from concept to something much more concrete? But first we'll take a detour. As a lot of us know in this room, the world of machine learning is evolving to increasingly encroach onto the world of software engineering. And the discipline's slowly but surely adopting best practices and principles while accommodating its own nuances around model development and model support. So there's a lot of key ideas such as testing, observability, and beyond that really start to apply to a lot of the machine learning solutions out there. But for today, I could talk about all of these things. I'm going to focus on the heart of what we tried to build and focus on the AI ML part of this project and try to discuss the decisions and the challenges that we face trying to build this solution. So machine learning products are data products. I could argue all software projects are data projects, but I think that's a presentation for another day. So to understand our solution, first you need to understand the data. We're going to revisit our old friend to help us do that. It's the dope Nike running shoes. So this is really a snapshot of what the data looks like associated with this product. You'll see things like the name and the description. So these are just text-based features. We see various other attributes as well. So as you can see across the two rows, the information varies slightly between our two clients. So Walmart and the fictional shoes.com. So as a human, we know this is the same product. We know these should be matched. But the big question is, how do you do this at scale using software like machine learning? So what I'm going to try to do is describe our solution step by step, Lego brick by Lego brick. So number one, first you need data. And luckily for me, Bazaar Voice has a lot of data. So the first step is to ingest that data, which is essentially made up of a historical backlog of millions of prior human product match decisions. So this is what we're going to use to train our model. That's the lens into the past that we're going to build our solution of. And I'll refer to these as candidates quite a bit going forward. Additionally, you may have heard the often true cliche that 90% of machine learning is not machine learning. And for a good reason, it's often true. And the next steps really do reflect this fact. So this is where we put on our gas mask and gear up for a deep clean. The next step was to eliminate a lot of redundant attributes and optimizing our non-tabular features, so with quite a bit of text. So for me, I try to equate this to shaping a block of marble and really trying to expose the natural features within the data, because we have a lot to choose from, so which features are significant. And a lot of this is uncovered in an exploratory data analysis phase, which comes with the territory in any machine learning project. So to make this more tangible, I think it's easier to showcase an example. So what does our data look like just before we put it into the model? Well, it looks a little bit like this. So across the top of this snapshot from a table, you can see our features. It just has the feature name. So these range from text similarity scores to booleans. Each row represents values or features associated with a given pair of products. For example, 2 pairs of trainers. And we need to use this information either to approve or reject a potential match. For example, you can see in our final column the MPM match, which stands for manufacturer product number, another type of identifier. We see for row 1, it's false, which means both products have different manufacturer part numbers. So we have a lot of future features in mind as well, and this is really just a small slice around semantic similarity scores and leveraging images and beyond that could really enhance this. And I could start to scratch a computer vision skill set as well. But for now, this was what we thought was a good start. Okay, so this is where it gets interesting. If you treat all of the steps in a machine learning solution like a team, I think a lot of us would agree the model is often the star striker. The model ingests the feature data and outputs a single thing essentially, and that's a probability. In our case, it's a probability of one thing, should we approve a match. And if that probability is high enough, we approve it. Otherwise, we just send it to the human reviewer. We're not taking their jobs, we're not knocking them out of the loop, they still have a role to play. So that's a really key idea. This is an autonomous system, but it's also extremely collaborative. So in terms of performance, what we found was our solution was as good as the human moderators and had an extremely high precision. I think greater than 99% precision. So every time we made an approval, we were right greater than 99% of the time. So that's success, right? Well, not really. There's an equally important piece of the pie still to be discussed. And that's that machine learning doesn't exist in a vacuum. But it's not that kind of vacuum. It's more of the vacuum space. We have a standalone machine learning solution, which is great, but on its own, it's useless. It offers no value whatsoever. Machine learning needs supporting software. So for me, I'm insistent that building any production software is a collaborative process of a complete product team. And furthermore, to articulate and build on what happened from our vacuum machine learning solution, you maybe think about what did the wider software look like? What was the architecture? So given I know we've got a few engineers in the audience, I think we'll dip our toes into some of the high-level design and talk about some of the thinking around it. So this is a simplified view, which is really an output from a 25-page design document, from which we landed on some really core principles. Number 1 was simplicity. We wanted a very simple to deploy and manage solution. Number 2 was rapid time to value. Because the process for so many years has been extremely manual, there's an enormous backlog of matches awaiting decisions. So to focus on that, we needed to get our data from somewhere as part of our solution. So our point of entry for our data was AWS Athena. And essentially what we did is we built a nested query to target all of the product candidates that we want to ingest. And we tried to decorate those candidates with product information, so the name, the description, and various other attributes. And all that information is then persisted just in a temporary S3 bucket, which is ready for collection by the next component. And this is the heart of the solution. So the heart of this, of what we built, is an AWS Lambda, and it has multiple responsibilities. It does some actually really interesting things inside it. Number one, it has a time-based trigger. So we want to invoke this Lambda several times per day. What it does is it first collects the results from the query, loads the model into memory, and prepares the data for entry into the model itself to get some results. But where it gets interesting is this paradox. This is a JavaScript Lambda, and our model has been generated in an entirely different programming language, in this case Python, using a library called Kedro, which does a lot of versioning and data management for us. So the big question you might have is how on earth is this model even running? So what we used to support this was the Onyx framework, something I've been a big advocate of for quite a while now, certainly a few years. And what it gives us is model interoperability. So we can build once and run the model anywhere. So we could run this on C if we really wanted to, it doesn't matter. So this stuff is actually quite innovative, especially at the time we're building this. There's no documented case online whatsoever of doing exactly what we've done here. And so this will be the heart of a few developer blogs in the future to keep an eye out for. So the fourth responsibility, now I've teed up the model, is to make predictions. And finally, the last step is it needs to integrate with an API that we own and run internally in Bazaar Voice that manages love and match information. We call this internally Mumford. Why it's called that, I have no idea. We have to ask someone else. And really what it is a large system in Bazaar Voice that essentially manages the entire life cycle of a match. So what we needed to do was leverage Mumford to trigger the syndication process. Now that we know two products have matched, let's make them syndicate and let's make the reviews share. So really what this boiled down to was a lot of application code coupled with a few database updates. So what you'll see across this entire solution is actually quite simple compared to how it could have been built. But there's a lot of nuance here in minimizing impact on several other legacy systems that are quite delicate, we should say. But the future of this solution is to make it increasingly event-driven, leveraging queues and more flexible horizontal scaling. But for now, this is effective and can deliver enormous value very quickly. So, now we have a solution, we need to step back and consider the big picture. And the big question is, how do you align technical promise with business value? How does this actually help the company? So we have one of our internal KPIs / OKRs on the slide here that we use to measure the benefit of any new software we introduce. And really this is a proxy for customer value. How does this machine learning solution get more bang from our customers' bucks in their partnership with Bazaar Voice? Well, there's two dimensions of value that we're measured against. If we direct our solution to the backlog of pending, long-running candidate matches, they're just sitting in a database and have been for years, there's a pool of 100 million we feel could be approved directly with the machine learning. The second dimension is a recurring benefit, and we expect this can approve about 16 million every year, and it's going to increase over time. So how does this translate into a bottom line, or a dollar value? I do have exact numbers, of course, but I'm going to put on my company hat and give you a ballpark estimate, and I'm sure my wrists won't get slapped too hard. As a body of work over the next 1 to 2 years, we expect this entire roadmap of work to be worth multiple millions of dollars for the company. So not only is this compelling technology, it's significant business value and benefit to the company as well. So let's look to the horizon. What we're doing right now is putting on the finishing touches of some of the functionality for this and prepping for the rollout. So keep your eyes peeled for various developer blogs on this work. But this project's really a representation of everything I believe in from a development context. It involves end-to-end unearthing value from discovery the entire way through to delivery, bringing product, engineering, and back office teams on a complete journey. And really what this is becoming is something much bigger than just a single delivery. It's a stimulant for increased investment in machine learning across Bazaar Voice. With that in mind, I put on my company hat once again. We are certainly hiring for people to come and work on problems just like this. So if you're interested, feel free to come and talk to me afterwards. But for now, I'm going to stop it there and thank you all for your attention. Thanks. And I think what we're going to do is take a 5-minute break just to give people a chance to consume more pizza, and then we'll pass on to Jordan Jones for his extremely interesting presentation. So we'll meet back here in 5 minutes. Thanks all. Yeah, I thought I'd give you a break.
Sorry, we actually got a question through on the live chat that just arrived now. How do you improve your production models on text? Just type me on the screen.
That one. I wish I could.
I think I won't do it. Yeah. Put it back in, I'm happy.
Stand wherever you're going to stand, just adjust the microphone. Yeah,
Like here? Yeah, should be all good. Try not to make any, keep it nice and stationary.
That will actually came through after normally you have to take questions with so we can time.
I'm happy. If you want to, yeah. Okay. Hi everyone. Okay. Apologies, I didn't know what else to put on this slide because I've worked very hard on the next few to introduce the title of my talk. Apologies if you did actually look at my Twitter, it's full of nonsense, don't go there. Yeah, so my talk is called Artificial Intelligence at this meetup, in this talk, localized entirely within your browser. You may be asking yourself, is it possible? My answer is yes. So to prove that, we are going to build a game of rock, paper, scissors. Everybody knows how to play rock, paper, scissors, right? Cool. Okay, well that's a good start. So why this? Because there is a chip shortage and scalpers everywhere, so it's impossible to get good current gaming hardware. So I am going to bring a gaming experience to you that can run in a browser window. But like, actually, why am I doing this? I guess. So I think other Jordan may have proved the point that AI is pretty powerful technology. You can do some pretty cool things. So the bits I'm going to focus on are very little effort, and the barrier of entry keeps getting lower. So these are the zone in which I like to live. I thrive in these zones. So I'm hoping I can bring you into these zones where you can create models and consume them with minimal button clicks. So this is all well and good, but how do we actually do this? Teachable machine. Okay, so Teachable machine is a tool created by Google. You may know them from the likes of TensorFlow. It's basically doing all that for you. So it's a very, very simple tool to use. I ran into it a few years ago when it was kind of lesser version of what it was. It's still pretty impressive, but you could train a model that classifies images. You could do it for like 3 classes and leave it in the browser. You couldn't do anything with it. Since then, it's gotten a lot better. You can do pose and sound classification in it, and you can add as many classes as you like. And most importantly, the model doesn't just stay in the window, and you can export it and start using it elsewhere. So it's a really good tool, and it definitely lowers the barrier to getting something up and running pretty quickly. An idiot like me can do it. So let's go to Teachable Machine. So once you get on here, you see there's a few different options here. So as I say, you can do audio or pose. I'm going to go with image. And there is the option of having standard image model or an embedded image model. So yeah, you can run the likes of the embedded one here on things like Arduinos and such. I'm just going to go with standard here. So now we're here. I'm going to use 3 classes. So I'm just going to add another one here. And the 3 classes in rock, paper, scissors are rock, paper, and scissors. Cool. Check my spelling. Okay, so from here, very simple to start actually getting data in here. One of the big problems trying to build remotely decent models is getting good data. So we're just going to get it straight from the source here and get it from my webcam if it would. Webcam cover is great. Okay, so from this point, I'm going to have to step away from the mic here, but all I need to do is just hold this button and do a rock.
Rock, yeah, that's close enough. I'll move it around a little. Okay, okay.
Yeah, that looks all right. So there are 189 rocks. Paper, let's go. Slightly more paper, but close enough. And finally, scissors. Okay, yep. All right, so what do we do from here? It's going to be this big train model button, right? But you do have a few options here. So there's these three parameters that you can play around with. For the most part, I would say that if you want a better model, if you find that this doesn't work by the end of it, just add more examples. These, for the most part, should do, but we'll go through them anyway. Epochs. That is a fancy word that sci-fi writers use. It is also the amount of times that our entire data set will pass through in training the model. So every single image will go through there 50 times. Batch size, it's basically how many of those are going through at one time. You don't really need to play around with batch size much. I should say as well, epochs, to a point, higher is better, but if you go too high, you run the risk of overfitting your model. So it's very, very good at classifying your training data and very bad at everything else. Learning rate, I would say don't touch this one. Google also say don't touch this one if you hover over it. But learning rate, the way I think of it basically is like, imagine you're trying to get to some distance ahead of you. Learning rate is basically the size of the steps you're going to take to get there. So if you take big steps, you're going to get there pretty quickly. You probably overshoot it, and you have to go back and forth, try and land on that point. Where if you take very small steps, you're probably going to hit it on the dot, but you will take forever to get there. So learning rate is basically like your journey towards this point of optimization, and that's you're saying basically how quickly you want to try and get there. But yeah, as I say, you can play around with these, but for the most part, you should be fine. Just hit train model here, and I will hit this just so that we can see what's going on here as it's happening. But once I hit this, you can see our model's just starting to train in the browser here, and it shouldn't take very long. Usually 20 to 30 seconds, we'll have something that's pretty reasonably good. Google is making a liar of me. Okay, so imagine it trained here. I did make one earlier, just in case something like this would happen. But so as it goes through, it takes about 85% of your training data here and uses that in training the model, and uses the final 15% for testing it. And then as far as validation goes, once that's done, you would have an option here that actually brings up your model, and you can start using it live in the browser here. So you can validate it by just trying it out again and making sure that the classifications are what you would expect them to be. But yeah, generally from a couple of hundred images on 3 classes here, it's pretty good. So we would then export it at this point. You would have the option of exporting it for TensorFlow JS or TensorFlow. I think there's another option I can't remember at the minute. So you can download it, which I've done, or you can host it, which will basically just give you a link that can serve up a JSON representation of your model. And with that one, they do minimize the security risk there a little, where your model is hosted publicly, but none of the data used to train your model is actually there. So worst case scenario, if somebody gets your URL, they can use your model, but they don't have access to anything you use to train it. So luckily, I downloaded one earlier, and I will bring up my little repo here and show you where that goes. So got a metadata JSON, got a model JSON, big one, and then this weights binary file, which we're not going to use at the minute. So jump back to the slides here for a minute. So I am not an AI engineer. I am a UI developer. Some people have affectionately called me front-end boy in the past. So React is my comfort zone, so I'm going to show you some React here. Not too much though. This is my model.js file, and this is basically all my interaction with the model here. So it's pretty small. Like most of the code base for the app I built is just React. I mean, you could do it in plain JS as well if you really wanted. So we can see here, there is an init method, so I'm just calling that on load of the page. All it's doing is loading the model JSON and the metadata JSON, and then we're good to go. Next one is the predictions. So I will just make a call to get prediction once I have the input here. So this input is just, it's an HTML canvas that we're going to pass in. So we're going to have a webcam feed. It'll just take a snapshot of that, and it'll just pass through the canvas. And we can pass that straight into the TensorFlow JS predict on our model that we created earlier. And that will pass back the array you see below. So for each one, there'll be the class name that we put in on the browser and a probability of how confident it is that our canvas input belongs to that class. So next bits, I'm just sorting it by probability and taking the first one. Could add a little check in here, say that I put some probability threshold in place that if it's above 80 or 90 or something, I want to, or 0.8, 0.9, I want to take it. I didn't do that. Good. And yeah, the other one was just a method that allows you to get an array of strings of all the classes that are part of your model. So in that case, I get an array with rock, paper, scissors. So as far as consuming that, I'm not going to show you the entire React unless you can check out the repo after. But the actual engine of our app here is basically just going to be, we're going to have a little countdown, 3, 2, 1, get ready to go. Then we're going to get the canvas, so that's just going to grab a canvas from the webcam that we've got on the page, and then next it's just going to pass that in and get a prediction. The bot is basically, it's just a random number generator. It's going to pick rock, paper, or scissors, not doing anything too intelligent. So we're going to score the round, and this is where I spent most of my time trying to code golf the way to score rock, paper, scissors. And then we're just going to update our scores and update the UI to show what the player and the bot picked. So I will bring up the app here and see if it works. Okay, so this is our app. I'm going to hit ready here, and it'll just count down on the screen, and once it hits 1, it'll grab what I'm doing, try and classify it. The bot will make a guess, and it'll score the round. So what do we want to go for, rock, paper, or scissors? Okay, we'll pretty strong showing from Rock here. Let's see. Okay, the lighting was a little different whenever I trained this, so let me see if I can use my torch here. That's more like it. Okay, but unfortunately the bot has picked paper, so we have lost. I heard of scissors last time, so let's try scissors. Okay, we lose again. But it correctly determined that we lost, so that's something. Okay. So yeah, like very little time and very little code. We've got something here that's pretty reasonably accurate at classifying us, providing you have the right and consistent lighting. So obviously, yeah, there's factors at play here where I make this model tonight. It might not work tomorrow if I take it home because I've changed the background behind me. I'm wearing different clothes. My arm's peeking in here. I decided to do it from this side. Like all sorts of variables, but you know, for playing around, getting something very quickly working that you can test out, this is pretty simple. So let's jump back here and have a look. So like, where could you go from this? I would say this as being, you know, a pretty effective tool for educating people and really showing them how easy it is to get started and actually building something. Yes, like the realities of enterprise ML are far detached from this, but this is great at showing people the concepts and getting them building something, and yeah, even just proving something out. Like if you want to make a quick and dirty model, you can train it up in here and export it and use it for whatever you like. But some potential projects that you could do here. So the icon set I used also includes lizard and Spock as options. So you could try and extend this and have 2 more classes. Things might start to get a little harder when there's a bit of ambiguity there. You can see Spock is very similar to scissors. So yeah, you can see like how it might cope with more classes and a bit more ambiguity in the gestures that you're doing there. Another suggestion, instead of passwords, maybe we could move to having secret handshakes with all our technology. Probably shouldn't say that. I work for a security company, but anyway. And I got last one. We're all going to be visiting friends and family over Christmas. They're going to be visiting us. If they try to enter your house, get a microcontroller. Try the microcontroller model. Try and classify faces and whether or not they're wearing masks. If they aren't, just give them a spray. So yeah, thanks everyone. The repo for the code is up there if you fancy having a look. There's a QR and the URL there. And yeah, thanks for having me.
Quick one, Jordan. Just while the audience are thinking of questions, we've got a couple through on the stream here. First question was, any preference to model download types? So TensorFlow JS, TensorFlow, TensorFlow Lite.
Yeah, I mean it really just depends on what you're planning on using it for. Like I am very much a JavaScript fanboy, so TensorFlow JS is definitely the one I would go for. But you do have quite a few options there, and even you can export it to use in the likes of Keras and stuff if you've got your preferred framework there.
And the other question, somebody who thinks you might have been cheating possibly, was the demo using the model from Teachable Machine?
It was using a different model from Teachable Machine, yeah. I did make one earlier just in the case that the browser would betray me in some way, and it did. So I was right. I have won that game even though I lost rock, paper, scissors. Thank you.
Thank you very much, Jordan. So I promised a bite-sized AINI event, and a bite-sized event you've been delivered. So I want to first thank the NIDC organisers. They made our life extremely easy in setting this up. I think they deserve a lot of credit trying to bootstrap the meetup scene here, so big kudos to them. And finally, a thanks to my other speaker, Jordan, and I just hope everyone join me in a final round of applause for both of those parties. Thanks, everyone.